please, I don't know if it's possible that we have a brief recap before we finally wrap up this course. Maybe
Yeah,
after the
yeah,
yeah,
for
after the
sure.
we just have
Yeah,
a
for
maybe
sure.
just
Yeah, for sure. And that's why during the lab sessions also, there will always be like a recap of whatever we've done. Even when I want to limit the theoretical part, there are some of these things that we need to understand, and that's why I'm not bringing the whole Microsoft Learn documentation, and that's why I'm sticking to this particular PowerPoint because it just what you need to know about those technologies. Yes, people can say, why are we not just doing the lab? Why are we not just focusing on the lab aspect, which is fine, but during meetings you are being asked some of these questions. Some of these times you need to understand. So surely there will always be a recap. At some point.
okay.
Especially during the lab session, for sure.
Okay. Okay. Thanks. Thanks.
So in today's class, what we're going to be looking at is how to administer network traffic, and nothing really. Yeah, we are just going to be looking at the network traffic. Last week we looked at intersite connectivity, and we talked about service chaining. Where we look at how you can actually configure routing and see how your network traffic are being not see because this because that's what we're going to be looking at today. But the last time you are able to say, okay, I want to configure how my traffic moves within my environment, and you have a virtual appliance as your nest up where you configure your own custom routing. You do not want to be dependent on the Microsoft routing. You want to configure yours so that your traffic goes through that particular appliance. So in today's class, we are going to be looking at how to now administer this, network traffic. So what are we going to be looking at? We are going to be talking about Azure Load Balancer. We are going to talk about application gateway, which is still part of Azure Load Balancer, but it actually sits on the network layer. Sorry, it sits on the application layer, which is the layer 7, of it sits on layer 7. And we're now going to look at the network watcher. Here, when it comes to troubleshooting, when let's say you want to connect from your on-premise machine to a resource in Azure, a service in Azure, and you're having connectivity issue, you want to check at what point is the traffic not being allowed. You want to check what service is actually blocking that particular traffic. So we use the network watcher. There are lots of services under the network watcher. We are going to look at them one after the other. So the first two here will be the load balancer and the application gateway. And like I said, the application gateway in Azure is also it's a layer 7 load balancer. It's also a load balancer. And when we talk about load balancer, what are we talking about? I'll just give you a scenario. I'm not going to define what the Azure load balancer does, and what the meaning is, but I'm going to paint a scenario, and you're going to understand what a load balancer does. Now, when you go to the train station, that would be a very good example, and you want to access the platform. There is always these barriers, where you need to scan your ticket before you go in. You know that everyone is still going into the station, is still going on the platform, but because they do not want to, create delays, you know, you can go through different doors, different barriers just to get on the platform. Now we have four people trying to access the same place, but they are actually going to different. Yes, they are actually going to different, barriers just to get on the platform, and that's what we the load balancer does also. But what we are trying to do is to make sure that traffic are not just going via the same path, via the same route. We want traffic to be distributed. You know, um, be distributed before why they are actually trying to get to the services or something. So we are just trying to make sure that traffic are evenly distributed. Sometimes it's not evenly. It all depends on our own configuration. But by default, we just want to make sure that those traffic are actually evenly distributed. And that's what we are going to be looking for. A typical example also, or another example would be you have a building, and this building I've got, or let's say a hall, and this hall has got like 5 doors, just because we do not want all the people to go to just one particular door because it's going to be too tedious, and we've got these other doors maybe as backup doors just to make sure that people can actually come into the hall, from different parts, from different doors, and that's the same thing. That's the same concept for load balancer. So what we're trying to do is just to distribute the traffic. Now, I said we're going to be looking at the application gateway, which is also a load balancer on its own, but it's not. I would say it's not like the default load balancer. It's just an application load balancer. Specifically, we use it for application load balancer. There are other load balancers also that we're going to be looking at, while we go on. So let's start with the introduction to load balancer, and what are we going to be looking at, when it comes to the Azure load balancer. We are going to be talking about the load balancer itself, how to choose a load balancer solution. Like I said, we've got different types of load balancer. It all depends on what you're actually looking for. Are you looking for a network load balancer, which is the layer 4 load balancer, or are you looking at implementing a layer 7 load balancer? Just like the application gateway. So we are going to look at how to choose a load balancer based on some prerequisites. We are going to look at how to implement public load balancer and how to implement internal load balancer. And when we talk about the public or the private or the public or the internal or the external, we are talking about the fact that one is being exposed to the internet and the other is just within the environment. So you should understand that when I talk about the public, I'm looking at traffic coming in and out, coming in from traffic coming in from the internet or going out to the internet. How can we load balance them? Back in the days, if you could remember when jam was a thing, and even when we want to go and check that 57, over 400 that we've got, we just everyone still rush to the cyber cafe, and there will be lots of people trying to check those results at the same time, and a normal result, or the result that you get within 5 minutes or 2 minutes when you go to the cafe, you would not even be able to get it, or retrieve those results within 30 minutes. And it's not just because a lot of people. It was because a lot of traffic. Yes, a lot of people means a lot of traffic because a lot of people are trying to access, and those back end servers were not able to handle those traffic. Now, in this case, when we talk about scaling, and that's where the scalability comes in. Now, when you talk about scaling, we can now create different servers, different workloads, different backend services that could actually handle those traffic coming in. But how can we now distribute the traffic evenly among all these servers that we've created, among all these backend services that we've created? Now, because if we do not have a load balancer and the traffic is still going, even when we have several servers, that could actually handle the same thing, and the traffic is still going to just one, let's say 90% of the traffic is still going to just one server, then it doesn't still make any sense because people are still going to be facing issue accessing their results. So now when you have the public load balancer, because we are connecting to the internet, because we are trying to get the data from the internet, now we'll be leveraging on the public load balancer in that regard. You should understand that when you try to retrieve something from the database, or when you try to retrieve information from a website, the website itself, the front end that you can see, that google.com that you can see, is not where the information is. That's just the front end. That's just what you will see. But the main thing comes from the database. Let's say you want to query your your name, you want to get information about a particular person. Let's say you work for a a pharmaceutical organization, and you want to get the information about a particular patient. When you put in the patient's maybe number, card number or ID, what they do in the hospital, and it's going to bring out all the information about that particular patient. It's not actually from that particular website. There is a database, connected to that website. There is a backend data. There's a database at the back end, and that's what the front end is actually interacting with, and that's what brings out those information. Now, this information are stored on the database. There is a connection from the server that is hosting that particular application and that particular database. If there is traffic from that particular server to that database also, there will be an issue from you retrieving that particular patient information, or if a lot of people are trying to retrieve different patient information at the same time. So what we can do is we can have multiple database, and we have multiple servers also. Then we can actually create like an internal load balancer to make sure that when the servers are actually requesting information from the database, they are actually, the traffic from those servers are being distributed, among those databases that we've created. So just think of it as, the same way we are trying to create our public load balancer to the internet when we want to get information. And that's the same thing when it comes to the internal load balancer. Then we look at how to determine the load balancer SKU, just depending on what you're actually looking for. So sometimes, like I said, SKU might be in terms of size, for some of those resources. Sometimes it might be, maybe what the capabilities, some of them might be premium, standard and the like. So but depending on the kind of SKU that we're looking for, it all depends on what we are trying to achieve. Then how do we create a load balancer rule? You would see Netflix, and you feel like, how does this work? A lot of things are actually happening behind the scene, and we're just going to be looking at that. So I just talked about the fact that we have different load balancer solutions. It all depends on what you're actually looking for. We have, from what you can see, we have application gateway, front door, load balancer, traffic manager. And from what you can see that some of them are just for applications, just like the front door and the application gateway. And how do I know this? You can see the protocol, say HTTP, HTTPS, meaning this is more of you accessing or getting something from the web, just the same way the Azure protocol works, and also the traffic manager. Now, and that's what we use when we want to determine the kind of load balancer solution. For the normal load balancer, we are just looking at, on the network layer, we want to distribute traffic, But for the application gateway, and the front door, this is specifically for hosting applications, because they've got some other capabilities or capacities, let's say properties or capabilities. Like when it comes to the security, we have what we call the WAF, which is the web application firewall. For every environment or system that we build, you want to have firewalls. You do not just want traffic coming in to go directly to your backend servers. You want to have something in front, like a firewall, where whatever traffic that is coming in will, get to first, and it will filter it out before sending, those requests to the backend server. So we can have, we have in terms of security, in terms of environment also, you can actually use this particular application gateway or the front door to load balance. It doesn't have to be your servers within the Azure environment. It can be, within Azure, within AWS, or even your on-premises server. So you can actually use load balancer, which is the application gateway or the front door, or even the traffic manager in front of these things. When it comes to using it regionally, like globally, you can leverage on Fondo and Traffic Manager. But the only difference between this Fondo application gateway and the Traffic Manager is you can see for the Traffic Manager, this actually helps in distributing traffic, across global, regions, and as against the application gateway, which is more of regional. It's not global; it's more of regional. But when you have the load balancer, which is but the only reason why people leverage application gateway and Fondo more as against the traffic manager is because of the added security, the web application firewall that you can actually use with application gateway and Fondo, as against the traffic manager, which doesn't have any additional or added security. So that means you need to create like a inbuilt firewall, or a firewall within your environment, then try to now redirect the traffic. But for application gateway, this has got its own firewalls and the like. So these are different types of load balancer solution that we have. But like I said, you just need to understand the fact that we are trying to distribute traffic, across our backend solution. And how do we do it? We'll do it by leveraging load balancer, and that's just the main thing. So for now, I think that's what you should be more concerned with, rather than trying to understand, which one is the ideal solution, at every point in time. So once you really understand this, but we're going to be looking at the application gateway, which will be the next one after this particular module. So you understand more about the application gateway. Now, this is the public load balancer, and this is what we're trying to do. Like I said, we are looking at traffic that is coming in or going out. In this case, it's traffic coming in into those particular servers. Now you can see this particular drawing here represents the internet. So the traffic comes in from the internet via port 80, which is the HTTP port. Now, if it was to be port 443, we're talking about a secure, HTTP port, which is the port 443. But now we're talking about port 80. But forget about the port 80 now. Traffic is actually coming from the internet, and when it comes in, we've got like 3 different servers that are actually hosting our application. Let's say we've got one, but because of the traffic, we've got scalability in place, and we have different virtual machines being spin up. But how do we now know that when we have 90 incoming requests, all there should be like a distribution to all the virtual machines behind the scene, all the backend virtual machine. So this guy should get 30 incoming requests, this guy also should get 30 requests, and this also should get 30 requests. Sometimes we do not even want to do it. It might even be the fact that on this particular machine we only have images, on this particular machine we have videos, on this particular machine we have text messages. Now if a user is requesting for text message from our own, or requesting for video on our own machine, or on our own internet, or sorry, on our own web application, the user should not be directed to this particular machine that is hosting just images, because the user wants video, or the user wants messages, just text. So accordingly, we need to have something that would distribute the traffic, that would check the incoming traffic and say, oh, this guy is requesting for videos, and direct that particular user to the virtual machine that is actually hosting those videos. So we have our load balancer, and based on the configuration that we have in there, those users will be directed to the machine that is actually hosting whatever they are requesting for. So that's what the load balancer. So you can see this guy maps IP addresses, public IP addresses and ports of incoming traffic to VM private IP address. So apply load balancer rules. Like I said, the load balancer rule that we've set in here, it might be based on what they are hosting, maybe images or something, or it might be based on the request number that we want to distribute. Sometimes we want to distribute it evenly. Sometimes we might say, oh, this machine has got more capacity, more, let's say memory space and the likes, and it can handle more traffic than this particular guy. So we want 50 traffic, requests to go here, and just 20 to come here, and just 10 to come here out of the 80. So it all depends on what we are trying to do when it comes to the rules. So, but as for the public load balancer, you can see, because all these machines here, they are private. Let's say our machine have got private IP addresses. We do not want to create virtual machine within our environment and assign or associate public IP address to them, because that's security breach. And Azure will always warn you when you want to create your virtual machine and you're actually adding, like a public IP address to it, and say, um, maybe it's not supposed to be for production environment. You understand? So you do not. You might want to add it maybe because you want to start accessing from your own virtual machine, and there are other ways you can do that by leveraging on other services, like what's this thing, the Bastion and the likes. you know so, but the major thing here is the fact that you want to just distribute the traffic, and you do not want to associate a public IP address with this. So you can create a load balancer with a public IP address and now map that particular public IP address to this private IP address of this guy. Now, what the customer sees is the IP address of this guy, and when they try to access any information on these machines, they get to this one, and this is the guy that now distribute it to whichever machine we've configured based on our load balancer rule. So, like I said, we've talked about the public, and we talk about traffic coming from the web, coming from the internet. Now let's talk about traffic within our environment, where we talk about the internal load balancer. I'm not going to be reading these one after the other, but you can actually see that we've got machines there, and this is happening all within our virtual network. All within the virtual network. If you see this other one, the incoming traffic is outside this particular virtual network, because the traffic is actually from the internet. But here, we are talking about traffic within our virtual network. We are talking about traffic within our environment. Now, if that is the case, we are going to be leveraging on the internal load balancer. And what does that do? Now, we've got a load balancer here. We've got different machines, and we've got different database, and those database have got information needed by this machine. Maybe we're trying to request, some information about the patient, just like the illustration I gave the earlier time, and we just need those machines to be able to access those information. Now, there might be traffic because we've got 3 machines accessing. Let's say we have just one database accessing one SQL at the same time. It might be a problem. So what we are trying to do is to make sure that we distribute this traffic coming from this machine evenly across this SQL database. So it doesn't have to be evenly, but it all depends on the load balancer rule that we've got in place. But like I said, what we are trying to do is just to distribute traffic from all these guys across all these guys also. Now, let's go ahead to look at the SKU, how to determine our load balancer SKU. So, like I said, sometimes it might be based on the size,
Excuse me.
it might be based on the capability. Yes, DJ.
Yeah, sorry for interrupting you, please. On that previous slide, I was just thinking, what if the database is within the VM? Let's take, for instance, the first VM. What if the database is within there? So there's no need there. I'm thinking, just asking,
Yeah, I understand.
that means that there will not be an internal load balancers.
Yeah, we can still load balance to that particular VM if it's there. We want to get those information from, but that's not for why do we want to have, a VM hosting,
The
our
database.
database when we've got, database services that we can leverage within Azure, that are even cheaper than you hosting your database on your virtual machine and the likes. Do you understand?
Or
You can have like a manage. You can even have like a managed, database in Azure. So why do we want to start installing or having our database on? Gone are those
or-
days when we have database sitting on our machines.
oh,
Now, like you said, the the service or the resource, the underlying resource is still the machine. You know, those databases are still seated on the machine, but now
yeah.
we've got like a managed, where it is only the database that you've requested for will be, assigned to you, so you don't even need to start. But even at that, we can actually, still create an internet load balancer to that particular. But that's not it's not an ideal solution. So
Okay, sorry for asking again. So what's now the role if we have a standalone like database? So what's the purpose of the VM? Is this just to receive the
So the way, yeah, I
net?
understand what you mean. Yeah,
Yeah,
the way this thing works. Now, when you have your web application,
yeah.
or your application, whatever, if it's web or mobile or something,
Mm,
like I said, information about users, are not stored on the application itself. Do you understand?
mm,
Now, those information are stored within the database.
mm.
This virtual machine is where your application is sitting. Let's say your application is actually being hosted on one of those virtual machines or the
Okay.
virtual machine. You understand? Now,
Yeah, I get,
this needs to interact with the database to get information. That means there
yeah,
needs a communication between your application, your
yeah,
application server and your database. So
yeah,
the VMs there are hosting the application.
yeah.
Then
Okay.
any information requested by the it's not static it's not a static website where when you go in there it's just for you to read information. But if it's a dynamic website where you need to log into, do you understand?
Yeah.
Username and password are not checked on the application, they are checked from the database. You understand? So all
Mm,
those information about the user are being checked. So if I want to log into, let's say, um, I'm a student of Unilad and I want to log into the portal, just to check my results. You understand? I put
yeah.
in my matric number and my password. So it's not my matric number and password is not sitting on that particular application. It's sitting within the database.
Yeah.
So the application needs to go and check, information from the SQL to say, oh, this user exists within this particular directory. This person is
Yeah.
a student, and that's when I'll get, information saying this is a long password. Can you input in a new password or a different password? This is the right password. Then you can access the portal.
Mm,
So
yeah.
the SQL, are where those user information are being stored. Yeah.
Yeah. Great. Thank you.
Yep. So thank you for that. Now let's talk about how to determine load balancer SKU. Nothing really. You can see, it all depends on what you are trying to achieve. Now you can see like the SKU here. There are two. We have the standard and the gateway. The first one says if you want to distribute traffic to your backend resources, like the last picture or image that we saw, we want to distribute traffic to the backend resources. We want to distribute traffic to, let's say I'm using an application gateway and just want to distribute traffic to the servers that are hosting my application, then I can leverage on the standard. Standard is enough for me. But if I want to direct the traffic, to network virtual appliance, let's say I've created a firewall, and I want to direct that traffic to that particular virtual appliance, I'm just using the load balancer as a gateway. In the case of, let's say, you can actually use that particular option in the case of a traffic manager, which doesn't have maybe security or WAF, incorporated within that particular resource or service. You can actually use the gateway SKU and just direct traffic to that network virtual appliance before traffic goes into your web application. So not really anything. So it's just you deciding on how the traffic moves within your environment. That's what this SKU is actually for. Now, when you are creating a load balancer, it tells you, do you want to pick a public or internal load balancer? Do you want this as regional? And when you talk about regional, you're talking about, let's say, application gateway, which is regional. If it's global, you're talking about traffic manager and the like. So all depends on the situation or the company's need at that particular time. An application gateway, oh sorry, and load balancer have got 99.99 SLA, which is service level agreement for Microsoft availability, saying, okay, with 99.99, your application gateway might have issues. I think that's like 7 hours in a year or something like that. So if you count the number of hours in a year, and we're saying, okay, it might. So if it's anything less than 7 hours, you are still within the SLA, you know, uh, which is fine, which is fine. So, but I've never seen, most applications or most resources down for 7 hours. Okay, I think I think we saw 3 hours of late or some month ago for Microsoft. Okay, so that's that. So let's now see how those applications. I'm not sure I want to start reading everything one after the other. So what I would just do is, before we even go to the application, to the
Hello,
application
Ravem. Sorry,
gateway.
I have a question.
Yeah, tell me.
Yeah, so I want to ask, like when you make a sub, speaking about Jam, their server being down. So does it mean they don't have a load balancer to be able to regulate
At that
the
time, at
mm,
that time it was, you know, no one was actually leveraging anything within the cloud. Cloud was not even a
okay,
thing. Yeah, it was this their server that was sitting within the organization. You understand?
okay,
And there
okay,
was there was I'm not sure they've got multiple servers hosting that same application. I'm so sure that application was just sitting on one server, and there was no way to load balance anything, at that time. So when the incoming traffic, you know, cannot be managed by that particular server anymore, then the the only thing you will get is just dragging, and people are not able to retrieve that results within minutes, within some minutes. Also, they have to wait a long time. So at that time, cloud was not a thing, and that's one of the things cloud has come to solve. When it comes to scalability. Yeah.
mm, okay, okay, thanks.
Yeah. So this is how the application gateway looks like. And I'm just gonna go. Sorry, the load balancer looks like. I'm gonna go to to Azure from here just to show you how we can actually create this. So we've got this is the client system, which is our own system trying to make, let's say, a get request, or let's say we want to get something, we want to retrieve our jam results. We're trying to make a get request to the internet, to maybe um, jump website. Now this is the front end, which is here. We've got the load balancer itself. Everything you can see here is the load balancer. You guys should remember when we were talking about public IP address, private IP address, and I was like, when you want to associate a public IP address or private IP address with a public IP address with your virtual machine, you need to associate it on the NIC card, which is the NIC. For application gateway or load balancer, you can do that with the front end IP configuration, and this is it. So within the load balancer, there is a place where you can actually create those rules, just like the NSG rules that we have. And you also have this front end IP configuration where you can actually associate the IP address. So when someone is trying to access Jamp now, I said for you to be able to access the information on this web server, that means this web server, the IP address needs to be somewhere, maybe within the DNS system, DNS server. And when you're trying to access this particular IP address, is now converted to the custom domain that you have, and this guy looks up and say, oh, this guy is trying to access Jam. This is the server that is hosting Jam, and it gets you there. You get the information. This happens within seconds, milliseconds, and the likes. But in this case now, we have a virtual machine that is hosting our web application, but this virtual machine doesn't have a public IP address. That means there is no way anyone will be able to access this machine because we've not associated any public IP address with that. So that means that particular machine, doesn't have any access to the internet and the likes. But we still want to access it. What we can do now is to create a load balancer, maybe an application gateway in this case, and create that with the public IP address. And that's why when you go on google.com, I was talking about Cloudflare and the like, and this is just you having like a proxy server in front of your application. So anyone trying to access now will not hit the server that is hosting those applications directly. The traffic will only hit the proxy server in front of those web servers, and that's the case here. So any traffic, any connection coming in gets to the load balancer, and that's where everything comes into play. So now let's say this machine hosts images, this one is used to host videos. Based on the rules here, when the traffic comes in, this is the IP address that will map with the web server now, not this one. This is the IP address that will map because the load balancer web IP address. So when you want to browse any information from these machines there, the traffic hits this guy because that's the IP address, right? That is actually attached to the custom domain, and it gets there, and people feel like, oh, we know the IP now. I know the IP of the web server. No, you don't, because the IP that you have is the IP address of the load balancer. So once it hits this guy, it checks within the rules to say this guy is trying to access video. Which of this backend server has got video on it? So the rules, based on the rules that we've configured, the rules will include the machine that is hosting that particular content. It will include the private IP address of that machine and the likes. It will include the content that particular machine actually hosts and the like. So based on that rules, the traffic will now be decided on which server it will be sent to. Which server will now be decided. So that is what the load balancer works, regardless if it's public or private. It might be private within your organization where you are all accessing this from a virtual machine still within your environment, but it's also going to check and say, what is this, what do we need to do. So there is always this rule that we call NAT rule that is attached to those VM based on the path that we have actually configured. So you would see what I mean by the path. It all depends on what you want, but I'm so sure you understand what the load balancer does with this particular diagram. It takes the traffic, it checks the rule, and redirect the traffic to the backend server that particular request is actually for. And that's what this guy does. So this guy says we should configure a load balancer. So I'm just going to take you guys to the Azure environment and see. Okay, so I'll do portal.azure.com. I'm logged in already, so it wouldn't be. So currently logging to the portal. The best way, like I said, for me, if I want to create anything, is for me to just search for whatever service I want to create. In this case, I'm going to use application gateway. Like I said, it's still one type of application of load balancer. So application gateway. So you can see the load balancer and content delivery. These are the load balancer. So if I click on here, it's just an overview. It's going to tell you we've got different load balancer. It all depends on what you are trying to look for. So Azure has actually created this within the overview. You can see best for application gateway. Sorry, best for web application. If this is actually for maybe regional load balancing. Basically, if you want something within maybe within your traffic to the SQL and the likes, but if it's just for application, you want to really have the security, also embedded security, a lot of things. If it's just actually for a layer 7 application, yeah, still an application with Google, then you leverage an application gateway. Front door majorly for content delivery. When we talk about the CDN and the likes, just the same way we have the traffic manager also. Yes, you want to leverage on, and I'm so sure you guys understand this content delivery. So we have our, let's say we have our application Jumia.com. Then Jumia.com has got, let's say, users from different regions, and we want to redirect you to the region that is very close to you. So we do not want, just because we've hosted this in South Asia doesn't mean people from Africa should go and access the one in South Asia. So we can have something in place, like a content delivery in place, where um, we can have like a caching, very close to the region where you are. So the first time you are accessing that particular application, it takes you to the one that is hosted in South Korea or in Asia. But the next time you are accessing, it will have been cached. So it takes you to access that particular web application from a region that is very close to you. And that's why you will see that the first time you are accessing some applications, it takes like 15 seconds just to open the front end. And when you reload again, it's just within milliseconds, and you feel like, oh, what's going on? That's just content delivery, doing its job. So if you clear up that particular cache and you try to do it again, it might take a long while. So if you want this global distribution, then you want to leverage on the Azure front door and the like. So yeah, so you can see this guy has been um, categorized. So for me, I want to leverage on the application gateway, because what I want is for an application that is being hosted on one of my backend server. So how do we create this thing? So I want to create an application gateway. Let's click on that, and you see how all this configuration comes into play. Now the resource group, I'm just going to pick a random resource group here. I'm just going to say test application gateway. I can say, okay, I'll pick a dex. This is the tier, which is fine. Do I want to enable auto scaling? We just talked about the fact that it will be best when you enable auto scaling, so that once the incoming traffic is more than what the web app servers can actually take, then more servers can be created and the like. What will be your instant counts? Maybe I want one, for at every point in time. I want these. Then how many maximum instant counts? Let's say, how many servers do you want to be created? How many services do you want to be want? At the end of the day, if you have traffic that is coming in, a lot of traffic that is coming into the application. Here is, are we going to create a new network or something like that? Network where the application gateway sits on. So I'm just going to say test app. Yep, I'm just going to add that, which is fine. Now you start configuring the front end. So the front end, I talked about the fact that let's say your virtual machine where your application, is hosted are actually not exposed to the internet. There is no there is no public IP address associated with those machines. However, those machines are where your web application are being hosted. How do you now expose that particular web? Because if people cannot access that machine, then there is no way they can access your application. So people need to be able to access your application. And how do we expose that particular machine to the internet? We need to add, let's say a public IP address so that we can actually. But that's not the case here. We still do not want to expose it, but we want user to be able to access those web applications. So what we can do is we can associate a public IP address if we are going to be exposing our application to the internet. We can associate a public IP address with this particular application gateway. We can actually associate a public if we only need this within our environment, or we can actually choose both if you want a public IP address and also you want to leverage a private IP address within the environment. So for now, I'm just going to click on the public IP address. This guy is telling me, so one needs to be created already. I'm not sure I have one, but I'm just going to pick one of these. Okay, already in use. Oh my word. Okay, so I'm just going to add a new application gateway test app IP. So I'm going to create it like that. Then this is where it now gets interesting. I've created an application gateway. Like I said, I'm actually associating a public IP address. So let's say I have 20.16, I have 192.168.0.1. That's a public IP address. Now, when I want to configure my, server so that the DNS server can actually catch where my custom domain is actually sitting, this is the IP that I'll be using. I will not be using the IP of the machine that are hosting my application. However, for those traffic to be sent to those web servers where my application is actually sitting on, I need to associate those servers with my application, with my application gateway. So how do we do that? We click on the backend, and this is where we now configure what we call the backend pool. The backend pool might be machine, VMSs, it might be even your app service. All depends on what we're looking at. So I'm just going to say test add pool, backend pool without target. I can say no. Then if you know the IP address of, and this is where you can actually even use a server that sits on your on-premises environment. It doesn't have to be backend server that is only seated in Azure or virtual machine seated in Azure. So you can see if I know the IP address of that particular machine, I can add it. The virtual machine itself, if it's within my environment, I can search for it. If I have a VMSS, which is the virtual machine skillset, I can use that also. Or if I have an app service within the environment, then I can add that to this particular backend pool. So for now, I'm just going to have this without any target, so which you can actually add later, and you can come back to configure, if you have got the target. And here is the front-end IP, which I've actually created. Here is where you create your rule, and so traffic coming in gets to this front-end IP. Then you've created a rule here, and the rule now sent to the backend pool. The rule now sent to the backend pool. Do you understand? So you configure your rule based on what you want to do. So the backend target, this is where the backend pool that I've configured, where I will be selecting it. I've selected the backend pool. What will be the backend target? I've not configured any target. If I do not want to, maybe I don't have a server, but I want to redirect that particular traffic. Let's say when let's say Access Bank. I know there was one bank that merged with Access Bank. I couldn't remember. So, and you want to now redirect all the traffic coming into that particular bank server to Access Bank, you know, but instead of just anyone trying to
Diamond Bank.
access that particular, yeah,
Diamond Bank.
yes. So anyone trying to access Diamond, bank application should be redirected to Access Bank. What I will just do is I'll come here to the redirection and I'll say yes, I want a permanent, redirection. I'll pick an external site, put in the target URL here. So the target URL will be here will be the where you put the Access Bank, but in the listener here is where you configure, let's say you are doing a multi-site or single site. This is where you configure the Diamond Bank, the URL. So any traffic coming into this particular host will now be redirected to the backend target. But if I have femi.com here, and femi.com is hosted on a virtual machine within my application, within my environment, this is where I configure the backend pool. The backend pool, then the backend target will be the web server itself. So I need to add a target to that particular backend pool. So I need to add settings also, what the pool name, what port is open, where can this be accessed and the likes. So that's what this is actually doing here. So you can see it's not as if it's rocket science. This is just the front end IP address which we have, which is where users trying to access. So if you try to access femi.com, that's just a domain name. That domain name is associated with a particular public IP address, and that's why you are able to access. So that domain name, this is the same IP, which is the IP of the application gateway, which will be associated to then the routing rule based on whatever you've configured. Where do you want to send your traffic to? How many servers? Is it based on parts, maybe images, or based on the number of traffic coming into that particular web application? So this is how you configure this. So I'm not just going to finish the configuration. I can go ahead, just add some random stuff, configure it, but yeah. I'm so sure we understand that. Uh, if you have any question at any point in time, you know, um, you can check within the server and see, help me choose, and that was what I was able to do when you click on, or when you go to, when you search for load balancer and click on overview, it's going to tell you what you need to know about each of them, and why you need to use each of them, depending on the solution you actually want. And yeah, we're actually reviewing the one. So now let's talk about the application gateway. I'm so sure you would have a an understanding of the application gateway now, based on that particular stuff I showed the other time. Now here we look at the application gateway. Application
Sorry.
gateway. Yeah.
I just wanted to ask, please. Can you actually do all this configuration using the Bash scripting? The CLI,
Yeah.
or
So
everything
you
needs to
have
be
to
created during the portal?
everything. No, not the portal. You can
Okay.
do everything via IAC, Terraform, ARM template, PowerShell, CLI. My former
Mm.
company, we hardly even use the portal. You understand? We hardly even use the portal. Even for some portal configuration, we have everything in Terraform. So you can use your Bash, you can use your, so it doesn't have to be portal. Portal is,
Okay.
UI is just, for you to be able to just see what you're doing, but it won't give you that consistent
Yeah.
interaction with those particular services. So for me, I would rather leverage on, the automation than you creating it manually.
Okay. Okay. That's fine. Thank you.
So here, how do we configure application gateway, which was what I was trying to do, and set up application gateway component. So what are the components and the like? And this is it. Now, here is the application gateway. Like I said, it's a load balancer that sits on layer 7, which is the application layer. We have your browser, which is where the client is coming from. It gets to the application gateway. Within the application gateway, we've got the listener where, I was telling you, let's say you want to redirect Diamond Bank to, the listener. When you configure the listener, the URL on the listener will be um, Diamond, and that's where every traffic coming in, will be listened to. Then, based on the rules you've configured, then your traffic will be redirected to the backend pool, which particular backend server is actually hosting that. So your backend pool might be virtual machine, VMSs, servers from on-premises, app services in Azure, regardless of what you really want. So it manages web application requests. So this one doesn't manage. It's not a network load balancer, which is the normal load balancer. This is an application load balancer, and that's why I've been saying, oh, application gateway sits on layer 7. It routes traffic to a pool of web server based on the URL of the request. Like I said, there is a listener. Within listener, you can configure the so let me take you back. Where are you, man? I hope I've not closed that particular. Thank you. So here, if I click on the listener, you can have like multi-site, and within the multi-site you can have single, or you want to have multiple host name. So I can configure multiple host name, .com. So if anything is accessed within all these particular multiple this host name, so if anyone wants to access this guy or access this guy, then it should redirect it to this pool. So I can have, let's say, within the backend pool now, I can have different machines hosting those different applications. You understand? Then I just want to redirect that based on traffic, based on whatever they are actually trying to access. Also, I can have what we call the path-based rules. The path-based rule in the sense that I have one single site here, which is femi.com. However, on femi.com, we've got videos, we've got songs, you understand, which is music, and we've got images. If the user is just trying to access, the music part, there is no reason why videos should be, presented to the user. So we can have what we call the path rule, where you now configure path to say, here, if anyone is trying to access the images, then this guy should be sent to this particular target. So I can configure the target settings here and add a backend target pool. So anyone trying to access videos or images should only be sent to this. Should only be sent to these. Let's see. They should only be sent to this particular pool. Do you understand? So this is what I'm going to configure. There will be a path, on what port, what's the name of that particular, let's say, image, and I create this, then I had this guy. Okay, let's say target name. I'm just going to give it the same name. Now that's the target name. If I want another one to say this is for video, now what is happening is, on that particular web application, femi.com has different endpoints. So I have femi.com/images, I have femi.com/videos. So what I've configured now is the one I configured earlier, which is from the video. That means anyone trying to access image should only be sent to that particular endpoint, which is femi.com/images. You understand? And if it's just for video, they should be sent to femi.com/videos. Do you understand? Then if it's just for normal static website, maybe sent to the main page, femi.com. I won't just configure any part here. You understand? I can just have something like this, and I just say, oh, maybe I just don't want to configure any part, or Okay, so I just have something like that, or if it's just for the videos, I have something like this, target name videos. Let me just complete this. Um, Backend settings, I can add another one. So just give me a minute. Same thing as so I configured the one initially. I'm just going to use the test. So here, what I'm trying to do is, regardless, depending on what the user wants to access, the user should only be sent to that endpoint, to that particular part. You understand? Based on my own configuration. So you do not need to say, oh, send the user to the front page first. Then the user can now redirect. That's why when you want to access this particular video, or you want to access this video, let's say Netflix has got, let's say Netflix also owns Spotify. On Spotify, you know that you want to listen to music. On Netflix, you want to watch videos. You want to watch, you know, um, movies and the likes. So we can have something like that, and anyone trying to access, if once you type in netflix.com and you're looking for videos, and it just redirects you based on the rules to say, oh, this guy is just looking for videos, send, so the user is sent to slash videos, and if it's just for the music, it's just sent to Spotify. So we can even have femi.com, but if you want to access video, you will be sent to Spotify. If you want to access music, you have to send to Spotify, because based on the rules I've configured. And if it's just videos that you want to access, you are sent to Netflix based on the traffic that is received from that particular browser, from that particular client. So we make that particular part base rule. So users are actually sent to where they need to be sent to. And that's what we're going to be looking at here. If you've got any question, just let me know. So this is the rule. We've got the list now, which is the femi.com, then the rule, then we now get this redirected. We get this redirected to the pool which is hosting that particular resource. And this was the path-based routing I was just talking about. On this particular path-based routing, we've got image, we've got videos. Same way you can actually use this for two different servers. Two different applications also. So if you want to redirect the user to netflix.com, or you want to redirect the user to spotify.com based on what they want. So in this case, we've got contoso.com, we've got fabricant.com, based on what the user really wants. You just redirect the user to. So a typical example, it might be based on location, just like when you are in Egypt and you type in jumia.com, jumia.com is going to redirect you to jumia.com. I think EG or EY, something like that. Then if you're in Nigeria, you are going to be redirected to jumia.com.ng. So that is actually, the rule is based on location in that regard. And that's why you'll be like, oh, okay, why am I being redirected to this particular, just like Amazon also. If you're in the UK, it's just direct you to .uk. If it's EU, it redirects you to .eu. You understand? So that one is actually like, the rule is actually a location based rule. So that's what, so you can actually use application gateway for that kind of routing, for that kind of redirection. So but it all depends on the traffic, where the traffic is coming from. In that particular regard, it's just based on location. Same here, where you have just one URL, just one web application. However, within the web application, we've got what we call the path-based rule, that I just showed you. So if the user just want to access images, the user is redirected to where the images are. Or if the user just want videos, it's redirected to the pool that is hosting those videos. So that's what we have here. And this says configure application gateway, compare it to load balancer. So we've got a lot of things to do, when it comes to the labs. So like I said, we're going to be doing all the labs for the virtual network by next week. So I don't want you guys to join from your phone. join from the system in case I call you to share your screen and show me. Um, Give me a minute, please. Okay, so let's go ahead to. I don't know what's going on. Still haven't been able to solve this my LinkedIn issue. The voice is still very low, even when I've opted for a different application. I think I just need to change my system. Maybe that's the problem now. Um, I think that's the problem now. Just need to change because I don't even know what else to do. All right, guys from LinkedIn, I'm so sorry. I would try as much as possible to fix this before next week. I'm just gonna test a different machine. Maybe that will sort it. The last one is the network watcher.
Sorry, Femi. Just wanted to mention, since the videos we're getting from YouTube are not, the audios are very low. So you are recording this one. Why not upload this on YouTube and take
I would
um,
yes, I will take that down and upload it.
yeah.
That's what I would do. I've got recordings because I don't know. They're very very low. They're very very low. Just give me a minute.
Okay.
I don't know. I don't know why. I was all fine when I started this particular course, and at some point, it just went bad. Like very. Oh my.
Yeah, even last week video, initially at the first 2 minutes was very clear and loud on YouTube,
Yeah,
but
yes, yes. Until I noticed it also, and it just went bad at some point. I don't know. It's just try as much as possible to make sure. It's just funny, but okay. Let's see. So the last one we're going to be talking about is actually the network watcher. Like I said, you just want to see the flow of your traffic, and that's it. When you leverage service chaining, you are the one determining the flow of the traffic. But let's say for troubleshooting purposes, you just want to see why is this traffic not getting to this particular destination, or what's the next up. You just want to know the next up, and that's why we use the network watcher. So we've got lots of other features within the network watcher. We've got the next up diagnosis. Like let's say you created a nest up and you want to see what actually the nest up is. What I created, is it really the nest up? The virtual appliance I'm using, is it really the nest up? You want to visualize your network topology. We were talking about the type of topology, and we mentioned the what's this thing? So there is service mesh. There is this one that is very common. Oh my word! What topology? Um, what is this? I think I've started forgetting. I'm forgetting things these days. So that was this topology we were talking about last week, where I said when you want to um, extend your network to the on-premises, um, not the star topology. What's this called? You people were not in class last week. How did I forget this? Um, okay, I would surely remember before the end of the class. So you want to check the network topology. you want to also see the IP flow, so you can actually use all these features within the network watcher to actually, do that. So you can see that lots of them. So connection monitor. Let's say you want to connect to a particular machine via RDP, and you want to just check if you are able to. If you are not able to, it's going to tell you why you're not able to. Maybe because of your IP is not being whitelisted. Maybe something is going to tell you. Majorly, it's just for monitoring that topology part. You want to just monitor, connection monitor. Also, you want to monitor. But if you want to check, let's say you want to troubleshoot. Now, connection troubleshoot, just like I said, the connection monitor would show you, how that connection is being made to that particular machine. But you want to have this connection troubleshoot. That connection troubleshoot is, I'm just going to show you this typical example. Just going to go away from this guy, and I go to one of my machines. If I pick this machine called Labs, and pick that machine, and I try to connect to that particular machine. But before I connect, I want to be sure that I'm able to connect to that particular machine. So I can have something like yeah, connect. No, so this is just diagnosis settings. Not diagnosis settings though. Let's see. Come on. Change inventory. No. No, 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 no. Should be connect though. So something like this. So it's just going to see. No, I don't want to configure that though. Okay, just give me a minute. I'm not troubleshooting. Come on. No way. Give me a minute. Give me a minute. Yeah. So it's under the help. Yeah. So here I can, I can try to connect to this particular machine and test the protocol if that particular protocol works. If I know the machine IP address, or the machine FQDN, I can use it and just run a diagnosis settings there, and see if I'm able to connect. If I'm not able to connect, it's going to tell me, based on this particular reason, you are not able to connect, so I can now troubleshoot that before I start, the connection. So here, that's what you're gonna get. For VPN also, it adds something related to connection. Let's say your VPN is not connecting and you want to check. So you have this VPN troubleshoot, which you can actually leverage. The Nest Up also, if you have the Nest Up, the Nest Up where you created like a virtual appliance and you want your traffic to hit that particular appliance, after hitting, maybe the front end IP configuration on your application, yeah, whatever application gateway, whatever you want to see, you can actually use the Nest Hub, the packet capture, the IP flow verify. You want to see, the way the IP flow actually works. NSG diagnosis. When you create an NSG, you know it's going to allow or deny, and you want to just check the NSG to show that it's actually working properly. So you can actually leverage on these effective security rule also. When you're creating an NSG rule and you want to be sure that it's actually going to be effective based on what you want or what you have in mind, then you can actually do that. We have something for the traffic, just for you to check the logs. You understand, like the flow logs, just the way you have the IB flow verified. That one you're just checking what's like the flow like. But this one you can see the logs. You can see, how the particular IP flow is actually moving, how the flow is moving, and also the traffic analytics. You want to analyze, the traffic, why coming in or going out of your platform. So you can actually leverage on lots of these network watcher features, but in general, we just say, oh, network watcher, and that's why when you deploy new resources within new resource group, you are going to see Azure deploying, some services, network watcher, East-US, network watcher, depending on where your resource is. So, and that's what, it's actually being used for. So, let's review the IP flow verifier. Like you can actually see, everything comes under the network diagnosis tools, the IP flow, the next up, effective security rule, VPN troubleshoot, connection troubleshoot, packet capture, and the likes. Now, for this one, you want to check the traffic from this particular. This is your own local machine, or let's say you are on VPN or something, or let's say you are within the Azure environment, and you've got this virtual machine. This virtual machine has got this particular IP address, and this is RDP port, which is port 3389, and you want to check, if you could actually connect to this particular machine, which sits on 13.24.35.46, same RDP port, which is port 3389. So you want to check if you are able to connect. Now, when you use this IP flow verifier, if you click on it, it's going to tell you why you are not able to connect if the connection is denied. And from what you can see here, you can see this guy is saying there is an NSG in place, which is the deny all inbound. If it's deny all inbound, then what I'm going to be looking at is, oh, there is this particular, deny all inbound NSG rule. Give me a minute, please. Just going to quickly show you that particular rule. Let's say I'm actually on my Azure environment and I want to connect to this particular machine and I'm getting that deny all inbound. So what I'm going to do is to go to the networking part of this particular machine, the network settings, and just give it a while. I don't know, Azure of late has been so. Then I can go to the network security group and check. This is what is actually denying all inbound. So it's an inbound rule. So deny all inbound. Why? So, and I can see is 6,500. If I want to allow that particular, then I need to go and configure maybe an inbound rule, of RDP for 3389, which will allow that particular connection, and it will override this particular one if I set the priority to an higher priority by adding a lower number, than this particular guy. So I know this is the guy, denying me. So all I need to do is just to create another rule to override that particular rule so that this particular machine can actually connect. So I can decide to say this is the only machine I want to allow, and within my NSG rule, I'm just going to add this particular IP address, as the source, and the destination is going to be this guy, and the port is going to be RDP port, which is going to be port 3389. So if I'm to do that, all I need to is just to set the inbound rule, and I'm just going to configure something related. So just hold on. So I want to allow this guy to access this particular guy, and I say source is going to be IP address, and I come with 10.1.1.4 as, the IP address where, and what will be the port range, because I know the port is going to be 3389, and the destination is also going to be an IP address, which is going to be 13.24 13.24.35.46, and the service, is RDP, so it sits on port 3389 also. I want to do a TCP, which is the protocol. You can see inbound TCP, and the action is going to be allowed. All I want to make sure is I need to create an inbound rule, a security rule, which is higher than this, this deny all inbound rule that I currently have. And once I do that, I will be able to access. So you can actually use the IP flow verify just to check, you know, what's actually blocking you from connecting. The same way you can actually leverage on the next up connection troubleshoot if you're connecting to a machine in Azure. If you're not able to connect, like, when you want to review the next up, you check the source IP and you want to connect to this guy, and you click on next up. It will tell you if it does goes directly to this guy, or maybe there is actually a virtual appliance in the middle that is taking um, that particular traffic before it even gets to this destination IP. In this case, it says the next up type is none. You've not created any next up. You know, it's just routing from here. So there's no virtual appliance. So it goes directly to that particular destination IP. So if you want to check the next up, you can actually check that. The network topology, like I said, you want to see what the topology is like, within your resource. So how things are actually configured. So when we talk about virtual machines, and I'm just going to go to the resource virtualizer. So you will see how this thing is being connected. What where the IP address, the public IP address are actually created, where it's associated to. If I've got an NSG, if it's associated with the um, subnet, or if it's associated to the NIC card of that particular machine, so you will know. So you want to actually use that particular troubleshooter, just to check, or visualize where things or how things are configured. So let's show that. I don't know why this guy is taking a while. What's going on, man? Come on. So you can see here I've got my disk, my lab. This guy is not even giving me what I want, but at least let's say, come on, go back. I'm just going to use the diagram here. So here you can see, here we've got this machine and this machine, which has got this guy have this NIC card attached to this guy. This guy have this NIC card attached to this second guy. We have an NSG which is attached to this particular NIC, but this second NSG also is attached to this one. Then we have the IP, which is the IP address. Like I said, when you want to associate your IP address with, because this one is the subnet network topology, so you are able to see. Now, if you when you want to associate an IP address, you associate the IP address with the NIC, same way you associate your IP address with the front-end configuration in an application gateway. So that's what you can see it. So this IP config 1 is attached to this one, or associated to this guy. This IP config 1 is associated with this guy. So you can actually see the topology, the way things are actually. So if I say no, I do not want this, I want my NSG to be associated directly to my subnet, and not the NIC card, or I want it to be associated to the subnet and also the NIC card. So if I check the network topology of my virtual machine, of my virtual network, I'll be able to see all the machines and everything that have been associated. Let me see if I could get my give me a minute, please. If that is going to work, that is the virtual machine, resource virtualizer, virtual network. Just give me a minute. Not Just give me a minute. Yep. So this is like the topology of, you know, the topology of one of my, VNet. So you can see this is the subnet, and this is the NSG. Same thing that I just showed you guys, but this is one machine, within this particular virtual network. So you can see this lab, this is the NIC card, and this is the IP config. This is the NSG, which is associated with this particular NIT, and I've got um, lab IP also. Okay, so I've got two IPs there. Just give me a minute. So that's the IP configuration. Yeah, that's the IP config. Sorry, this is the IP itself. Yeah, and this guy is associated with this guy, and this IP is associated with this config, and this guy. So like I said, this network topology gives you access to whatever you need to see and how things are actually arranged within your environment. So that's that.
Sorry. What's the essence of knowing the topology?
You can actually visualize your, the networking representation. You can see how things are connected. So normally, as an architect, as a network architect, you cannot just go in there and start deploying things. There should be like an architectural diagram, like a topology already on how we want things to be connected. Do you understand? So
Uh,
that gives you this gives you that visual representation, like like it has been written here. You understand? So you can
mm.
see how things need to be connected, how you want things to be connected. Yeah. So that's what this network topology gives you. So especially when you leverage on the why did I keep forgetting this type of topology? Just give me a minute. Let me check this one. There's this particular one. I don't want the boss, man. Yeah. Just give me a minute. Yeah. So not the start topology, man. Mm. I can't even say it, but yeah. So basically, that's what the network topology gives you. To just visualize visual representation of your networking elements. You know. All right. So that brings us to the end of this particular, network module. Like I've said, next week will be labs, for all the network modules that we've actually discussed, talking about the virtual networks, talking about the inter-site connectivity, where we're going to be looking at the um, VPN, site to site, point to site, or express route, and talking about the load balancer itself, where we talked about application gateway and some other ones, like the traffic manager and front door. Also, the network watcher. So, we're going to be looking at all this during the next class, which is going to just be labs. We're not going to be doing this. So, we might end up creating VPN just to see how we could actually connect. A typical example is for us to create like a database in Azure and try to connect using SIMs, these um, studio from our on-premise machine to that particular database. So if we are able to access that database, without issues, then we know that our VPN is actually working. So you see how to install the VPN on your local machine also. So I think that will be one of our project, but we'll look at it also. So let's look at the labs and see, how things can actually interconnect, in the next class. So let me know if you have any question. If not, we can call it a day. All right. So we'll call it a day since we don't have any question. I'll talk to you guys next Saturday.
Thank you
Okay,
so much.
bros.
Thank you.